Unit 0 notes, Math 1340, page number 4. Factoring the greatest common factor for a polynomial. The greatest common factor, GCF, of a polynomial is the largest polynomial that divides evenly into the polynomial. Here are some problems to practice pulling out the GCF. Number 1, we have 30a plus 80. We have two terms here. And we want to find the greatest common factor. As you can see here, we can divide the first factor with 10 and the second factor with 10, which means we can pull 10 out as the greatest common factor. So if we pull 10 out, and now to rewrite the remainder, we divide each of these terms by 10. 30a divided by 10 is 3a plus 80 divided by 10 is 8. Notice that the resulting polynomial doesn't have any more common factors to pull out. So the greatest common factor is 10 in this case. The next question, 7x plus 28x squared. So first we look at the numbers. What is the greatest common factor between 7 and 28? The answer is 7. Both numbers are divisible by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. So that is the first number I'm going to pull out. And now, notice how we do have more common factors. Notice here we have an x, and here we have two x's. So if I rewrite this expression, this is basically going to be 7x plus 4 times 7 times x times x. So far, we recognize that 7 is a common factor. Another common factor is the x. So if I take 7x out, because that is what's common between them, that is the greatest common factor. Now we write the remainder. Now we divide the first term, 7x, by the greatest common factor. We get the answer 1, plus we divide the second term by the greatest common factor. We get what's left, which is 4x. So plus 4x, and here is the polynomials factored using the GCF method, or pulling out the GCF. Number 3. Number 3 here, you will notice that we have 2x cubed plus 6x to the fourth plus 10x to the fifth plus 3. So if I wanted to break this down, this is basically 2 times x times x times x plus 6 is 2 times 3. So 2 times 3 times x times x times x times x plus 10 is 2 times 5 times x, 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 and then the last one is plus 3. As you notice here, when it comes to numbers, we do not have a common factor. The only number in the first one is 2. It is a common factor with this one and with this one, but not with the last term, as you can see. So it is not a common factor. I cannot pick it to be a common factor. When it comes to the x's, I have 3 x's from the first term, 3 x's from the second term, 3 x's from the third term. However, the last term, the constant, does not have x's. So again, I cannot pull any of the x's out as a common factor, which makes this polynomial here is in the simplest form, and I would not be able to pull out a common factor from the whole polynomial. So in this case, we're going to say no GCF. Number 4, we have 10y to the fourth plus 5y cubed plus 45y squared. If we look at the numbers, we notice that the greatest common factor is 5. Every single number of these is divisible by 5. So I'm going to pull out 5. And then the highest variable that I can pull, or the highest power that I can pull, is y squared. All of these numbers are divisible by y squared. So I can pull y squared out. Now, if I divide the first term by 5y squared, I will get 2y squared plus 5y cubed divided by 5y squared is y plus 45y squared divided by 5y squared is equal to 9. And the greatest common factor is this number. So let me highlight all of the greatest common factors. Actually, let me use a different color. So I will highlight that in orange. So all of these are greatest common factor, and we don't have any greatest common factor for number 3. Let's learn how to factor a trinomial with a leading coefficient of 1. So a trinomial is basically a polynomial that has 3 terms. Typically, it is the square term and a linear term and a constant. So if we have a polynomial of this form, x squared plus bx plus c, notice how the leading coefficient here is 1. That is what we call a leading coefficient. That is the coefficient of the highest power term. First, we're going to list all of the factors of c. So we look at the number c and list all of the factors of c. Then we're gonna find 2 factors of c, which we're gonna call p and q, such that they add up to b, which is the middle term coefficient, the coefficient of the middle term. Then the factored expression is going to be x plus p times x plus q, the p and q that we found from the previous question. So let's take a look here at our first example. If we want to factor x squared plus 2x minus 15, notice how the leading coefficient is 1. Now, b is 2 and c is negative 15. Make sure you take the negative sign in here, and b is positive 2, so that's why it's 2. So we want to find 2 numbers such that their product is negative 15 and their sum is equal to 2. So we know that since c is negative, we know that the 2 numbers we're looking for, one is going to be negative, then the other one is going to be positive. And since the middle term is positive, that is the addition of both of them is positive, we know that the bigger number is going to be positive. So I'm thinking about 2 numbers here, negative 5 and 3. That is a possibility. However, because of my observation here and the middle term is positive, I know 5 cannot have the negative sign, because if we add these 2, the answer will be negative 2, and that is not the middle term. So what I will do, I will say, not this option, it is the other option. It is 5 and negative 3. 5 and negative 3. Now, if we multiply 5 times negative 3, we get negative 15. If we add these 2 together, we get positive 2, which means those are the correct factors. And that's why we can factor our trinomial as x plus 5 times x minus 3, because the 3 here is negative. So that is what's going to happen if the leading coefficient is 1. As you can see, it is the 3 steps that we did, and with practice, you're going to be able to do that really fast. When it comes to factoring a trinomial with a leading coefficient that is not 1, the leading coefficient is not 1. For example, we have a trinomial of the form ax squared plus bx plus c, such that a is not 1. A is not 1. It's another number. First, we're going to use the AC method. So we're going to take A and C with their signs. So A and C with their signs and multiply them together. And then we're going to find all of the factors of the product of AC. Okay? Step number 2, we're going to find 2 factors of AC. We're going to call them P and Q, so 2 numbers. such that their sum is the middle term b. Their sum is the middle term b. And then we're going to rewrite the original expression as ax squared doesn't change. We're going to split the middle term b into px plus qx, which are the two numbers we found that they add up to b anyways. Then we're going to group the first two together, the second two together. Sometimes we need to switch p and q together in order to obtain a nice groups that we can factor. So, and then we're gonna take the greatest common from the first group, the greatest common from the second group, and we have to end up with a number that we can factor out as the greatest common factor from the entire expression. It's kind of vague when I say the steps, however, with practice, you will be able to get the idea. So I'm gonna work this example right here. I'm gonna work it in the space provided here, just to give you a better idea. So let's say we want to factor 5x squared plus 7x minus 6. I know that a is 5, b is 7, and c is negative 6. So I notice that a is not 1, which means I need to multiply a and c together and find AC. So AC is equal to 5 times negative 6, which is equal to negative 30. Now, I want to split up negative 30 into two numbers so that the product of those two numbers is AC, and the sum is the middle term, which is 7 in this case, b, which is 7. The factors of AC are, I have several options. I have a negative 10 and 3. I have 3 and negative 10. I have negative 6 and 5. I have 5 and negative 6. So those are my options. Let's see which options work. So we need the sum to be 7. If I made a mistake here. I did this backwards, okay? So negative 3 and 10. Okay, so let me test. Negative 10 plus 3 is negative 7. That is not 7, so that is not an option. Negative 3 plus 10 is 7, so that is an option. Negative 6 plus 5 is negative 1, not an option. 5 plus negative 6 is negative 1, that is not an option. Oh, I repeated the same mistake here. So let me actually fix that. I meant to say the negative 5, but it's not going to work anyways. So the only option we have is the two numbers I'm looking for are negative 3 and 10. Now, I'm going to rewrite the middle term so it's the sum of those two numbers. So I will keep the first term as it is, 5x squared, and then I will have plus. Now, I notice that the first number I have here is 5, so I will choose the number that has a common factor with 5, which is in this case the 10. So I'm going to say plus 10x here. And then I will say minus 3x because the 3 is negative in this case. Minus 3x. And then I will keep the last term, which is negative 6. Okay? So I chose strategically such that the number I choose here has a common factor with the previous one. And the number I choose here has a common factor with the last term. Now I'm going to regroup these two into two groups and then factor the greatest common factor out. Let me just make sure that I am clear here. So let me actually erase this. And I will say, okay, plus negative 3, plus negative 3x minus 6, this way. I'm going to regroup now. So I will take the first two terms together and the second two terms together. Notice the greatest common factor of the first binomial that I created here is 5x. So if I pull 5x out and then plus from the second one, I have -3 as a common factor, so I will pull it out and then I will put the remainder in between the parentheses. Now, if I pull the 5x from the first binomial, I will have x plus 2 remainder. Now, if I pull -3 out from the second binomial, I will divide each term by -3. -3 divided by -3x is positive x. -6 divided by -3 is positive 2. Notice here how I have this, which is the last step, by the way. This is the factor I'm looking for that can be pulled out of the total polynomial as the greatest common factor again. So notice how this is the greatest common factor in the whole trinomial, or the polynomial in this case. So I'm going to pull that out as a common factor. I'll finish the work here. So if I pull x plus 2 out as a common factor, so pull this out, the remainder is going to be 5x minus 3. And now I have a product of two binomials, which is the typical factorization of a trinomial. And that is exactly what we have here. Okay? If I did not end up with, let's say, this similar to that, that means my arrangement of these two terms in the middle needs to be switched around. That is what that means. Unless I have these two the same, I will not be able to proceed to the last step, which is the step right here. So I hope that is clear, the AC method. With practice, hopefully it's going to become more clear to everybody. Okay. The third type of factoring is the difference between two squares. So if you have a binomial that is a difference between two squares, which is usually of the form a squared plus b squared, then we can factor these types of binomials using this method. It's going to be a plus b, which is basically square root of first term, square root of the second term. We add them. And then times a minus b, which is square root of the first one, square root of the second one, and then we subtract them. So let's take a look at an example here. If you have 9x squared minus 25, notice how the first term is a complete square, the second term is a complete square, and the sign in between them is minus. So we're going to take the square root of the first term. So the square root of 9x squared is basically square root of 9, square root of x squared. Square root of 9 is 3. And square root of x squared is x. Basically, they're going to cancel together. So now we're going to take the square root of 25, which is positive and negative 20, positive and negative 5. So now we're going to say the factoring is going to go like this. The square root of the first term plus minus the square root of the second term, which is 5 and 5 in this case. And that is how we factor the difference between two squares. Here is to the practice. Factor the following polynomial expressions using the appropriate method. So for number one, I will use factoring a trinomial where the leading coefficient is 1. So I will take a look at the last term, and I will have to figure out two numbers such that their product is 6, but they add up to -5. Because they add up to -5, I know that both of them has to be negative. Both of them has to be negative because their product is positive, but their addition is negative. So both of these factors have to be negative. Okay? In other words, when you see that the sign of the last term or the constant is positive, that means you have similar signs. And these signs both are going to follow the middle term sign. So I know immediately that first I factor the first term, so x squared is x times x. And then I know that both signs have to be negative because the sign of the last term is positive, but the middle term, so the both signs of the factors are going to be the same, and they're going to take the middle term sign. Now, two numbers, if you multiply them, you get positive 6. If you add them, you get negative 5, is 2 and 3. So that is how you factor that first trinomial. The second trinomial, the leading coefficient here is 6, it's not 1. So I'm going to find AC. AC is equal to negative 6. Now I will find all of the factors of AC, which means what makes up negative 6. So I have, the options are negative 6 and 1, negative 1 and 6, negative 3 and 2, negative 2 and 3. These are the options that I have. Now, which one of these is going to work? I will add them together, and whatever adds up to positive 1 is going to work out. So, negative 6 plus 1 is not positive 1. Negative 1 and 6 doesn't work because it's not positive 1. Negative 3 and 2 doesn't work because the answer is negative 1. And the last pair works. So now, I know that if I pick negative 2 and 3, the answer would work. So now, I will write the first term, 6x squared, and then I will add something in the middle and then minus 1 at the very end. Now, I can choose 3 or negative 2 for the first term. So, if I choose negative 2, so negative 2x here, and then plus 3x right there. That probably would work. I'm not very comfortable with this choice, so let me switch it around. So I will say instead of that option, I will go with plus 3x minus 2x instead. So in this case here, I will rearrange the terms. So I will take the first two together, and then the second two together. Remember, there is a plus sign in between them. The negative is the sign of the 2, and there is a plus sign in between. So I will take 6x squared plus 3x as a binomial plus negative 2x minus 1 as another binomial. The greatest common factor from the first binomial is 3x. So if you divide the first term by 3x, you get 2x and then plus 1. 3x divided by 3x is 1. And then the greatest common factor from the second binomial is negative 1. So if you take that out, you get 2x plus 1. Basically, the negative 1, when you pull it out, it changes the signs of each term afterwards. Now, notice how I got what I wanted. These are the two factors similar, so I will pull these out as a common factor. So 2x plus 1 is the greatest common factor, which means now I pulled these out. The remainder is going to be 3x plus minus 1 is minus 1, basically. And that is the final factorization of the problem here. So let me just put some room here and shrink that a little and then put it right there so I have space for the next one. Number 3, 81y squared minus 100. So as you see here, the first term, 81y squared, is a perfect square. That is a perfect square, and then 100 is a perfect square as well. So I will use the difference between two perfect squares to factor that. So the factorization is going to be the square root of the first term. So square root of 81y squared is basically 9y. So I'll put 9y here and 9y here. There is a plus, there is a minus, and then square root of 100 is 10. So I will put 10 here and 10 there, and that is the factorization of number 3. Number 4 is similar. It's a perfect between two squares. Square root of 9x squared is 3x. There is a positive, there is a negative. Square root of 1 is 1 and 1. Number 5. The leading coefficient is 1, so I will look for a number. Their product is 32, and their sum is 12. 32 and 12, so that is 4 and 8. Positive 4 and positive 8. So the factorization is going to look like this. The square root of the first term is x and x. And then the sign of the last term is positive, which means both signs in the factors, the binomial factors, are the same, and both of them are positive. So here is a positive, here is a positive. I'm looking for two numbers. When you multiply them, you get 32. If you add them, you get 12. That is 4 and 8. It doesn't matter which one goes where because both signs are positive. The last one, the leading coefficient is not 1, so I will have to find AC. AC in this case is equal to negative 60. Now, I need two numbers. If you multiply them, you get negative 60, and if you add them, you get negative 4. So the first thing that comes to mind is, let me write all of the factors actually. So all of the factors of negative 60, I have negative 6 and 10, 10 and negative 6. I have 15 and negative 15 and 4, 4 and negative 15, negative 4 and 15. I did the same mistake here, so negative 10 and 6. Okay, so those are the options that I can think of. Let's see which ones, if you add them, you get negative 4. So if you add negative 6 plus 10, you get positive 4. That is not an option. Negative 10 plus 6 is negative 4, so that is an option. And the rest are going to result in negative 11 and 11, which doesn't work. So our option is negative 10 and 6. Now, I'll finish the work here. So I'm going to write the first term as it is, and then the middle term, I will split it into 2. So if I choose to take the the negative 10 with the 4, I will have a common factor of 2. So let me try that. So negative 10x plus 6x minus 15. Let's see if that works. It might work. If I take the first two factors together and the second two factors together, now the greatest common from the first binomial is 2x. And what remains is 2x minus 5. 2x minus 5 plus. The greatest common from the second binomial is 3. So if I take 3, the remaining binomial is going to be 2x minus 5. So I ended up with, these are the same, so I'm going to pull them out as the greatest common factor. So I will pull 2x minus 5 as the greatest common factor, which means they're gone now. The remaining binomial is going to be 2x plus 3, and that is the last factorization of number 6. These are pages 4 and 5, and these pages cover all sort of factorizations that you will need to proceed to chapter 1 or to proceed to the rest of week 1 work.